Still loading. Okay, there we go. So question 3, use the normal probability app to find the combined area under the standard normal curve that is to the right of z equals 1.358.
Ollie, you want some more yogurt?
And to the left of the negative. So that one and that one.
Yeah.
So I got the area of 0.1745. Is that what you guys got? Okay.
What I got.
It would just be 174, right?
Yeah.
Okay. Which of the following will have a smaller standard deviation? I know. So the standard deviation is smaller if you do the sample means, right?
Yeah.
Because it's divided by the square root of n.
Mm-hmm.
Okay. Which of the following results implies that the spread in it decreases as the sample size increases? Is that the central limit theorem?
I think I'm not.
Or is that the law of large numbers, actually? Where is... I need another iLearn tab. I think that was in lesson 6 that it talked about that.
Yeah.
The law of large numbers. The law of large numbers states that the sample mean x will be closer to u. Is that what it said? Decreases as the sample size. I think it's the law of large numbers.
Yeah.
If it's not, then it's going to be the central limit theorem. We can do it the second time. Okay. Scores of the quantitative portion of the GRE are approximately normally distributed with a mean of 150.8 and standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to that? So z is just the number. So 160 minus 150.8 divided by the standard deviation, which is 8.8.
Mm-hmm.
Okay, I got 1.045.
Yeah.
Is that it? Okay. It's the probability that a randomly selected student will score above 160 on the quantitative portion. So is that just the area on the normal probability app over that z-score?
Yeah. So it's,
Not under, just over. So 0.148.
yeah.
Random sample of 5 students was selected to take the GRE. Their scores are. Okay, so we have to find our mean ourselves this time. One, two, three, four, 5.
Oh.
All right, so is the mean 160? Is that what you guys got?
Mm-hmm.
Okay. And then what is the z-score corresponding to the sample means? So how do you do the z-score equation? Because we would need one number. Or do you just do that 160 minus and use the mean from above? Does that make sense? So like do 160 minus 150.8.
Yeah, I don't.
That's the only guess that I have.
Yeah, I bet, because I can't figure out what
Hey,
number
Holly.
then.
Yeah, that's the only idea I have. And then divide that by the standard deviation, which was 8.8,
Yeah.
divided by the square root of 5, right?
Mhm.
So that would be 2.337. Are you saying hi? Okay. So yeah, my guess would be 2.337. No, 2.338.
Okay. Yeah, that's the only way I'd figure.
I don't know if that's going to be right, but what's the probability that 5 randomly selected students will have a mean score that is greater than the mean? So then if we were wrong on that one,
Yeah, that's one of the.
that's going to be annoying. Okay, so that's going to be the z-score, so we could enter that in 2.338. And was it above or below? Greater than.
Greater.
So then it would be 0.0097.
Mhm.
Does it say 4 decimal places? At least it was the right number of decimals, so that's good.
Yeah.
Okay, suppose the mean GPA of BYU Idaho students is 3.5, standard deviation is 0.7, and it's right skewed. What is the shape of the sampling distribution? So that one's still going to be approximately normal because of the law of large numbers, right?
Mhm. Yeah.
Okay. I remember thinking that was weird in the video, but that's what he said. So.
Mhm.
Okay, what is the mean of the distribution of the sample means? So that would still be 3.5, right? For question
Yeah.
11. Okay. What is the standard deviation of the distribution of the sample means? So the standard deviation is that is it the mean over the square root of the number?
Think so, because I don't see anything. Yeah, I think that's from lesson 6.
Yeah.
Yeah.
Okay, that one's 3 decimal places, so I got 0.389.
Mhm.
Okay. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So we just need the z-score for 3.3, right? 3.3 minus, was 3.5 the mean? Yeah.
Yeah.
And then that's divided by the standard deviation, which was, 0.7, there it is. And then it's the probability, so we have to put that into the z-score thing. 286.
It was less.
And less, yeah. So just to the left of it, I got 0.3874.
Yeah, that's what.
I guess it's just 387, right? 3 decimal places, yeah. Okay, what is the probability that the mean GPA for 81 randomly will be greater than 3.3? So that's the same chart, just the other two. So 0.613.
Mm-hmm.
All right, question 15. United States Coast Guard assumes the mean weight of passengers in commercial boats is 185. Previous value was lower, but was raised after a tragic boating accident. Standard deviation of passenger weights is 26.7 pounds. Too much reading. So we're finding the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. I don't know how to do that. Do you know how to do that? My guess is that we just find the z-score of that 177.6 pounds over the 48 being n, but then I don't know what to do with that. So I guess I'll figure that out. So it was 177.6 minus that mean of 185 over the standard deviation of 26.7 divided by the square root of 48. And then if you put that in, 92. Okay. So that is as extreme or more extreme. So I think that just means all the way to the left and all the way to the right, because it's just extreme, not just less than or greater than, but that far away. So that in that case, I would have 0.055.
Okay.
We'll go ahead and submit that. See how it went. Well, we got that one right. So we got 12, 13, and 14 are wrong because we didn't understand that one. So that makes sense. And get back in. All right, so Andrea, we just got 12, 13, and 14 wrong. Did you have any others, or is that same? Same? Okay. So let me put in, we did get 15, right? Okay, so 12, 13, and 14. What is standard deviation, the distribution of the sample means? Yeah, I just don't understand what that question means. Was there anything in the chapter about that? Let's see if I can just Control F and find. Okay. The mean of the distribution of sample means is the population mean. The standard deviation of the distribution of sample means is the standard deviation over the number. So we would need the standard deviation of the original set first, and then do that standard deviation divided by the square root of the number. So Was this the same as that, the GPA BYU Idaho students? Is that what they're
Yeah.
talking about?
Hmm.
Okay, so that standard deviation is what we need. That makes sense. Never mind. That
Yeah.
totally makes sense. It's 0.7 divided by the square root of 81.
Yeah.
So in that case, it would be 0.078. And then I can put that into the probability applet, and we'll just really hope that we're right. Because if you get one of these wrong, you kind of get them all wrong.
Yeah.
Okay. And is it less than 3.3? So then I got 0.531. Does that sound right?
Yeah, that's what I just put in.
Okay. And then one more. The probability that the mean GPA for 81 randomly selected students will be greater than 3.3. So not those two, but that one. That would be 0.469. And then we hope for the best. Okay, so I got 12 right, but still 13 and 14 wrong.
Huh.
So if you haven't turned it in yet, I guess you could try and figure those ones out. It's too late for me, but
That's so weird.
the probability that the mean GPA will be less than, I don't understand why that's. Oh, wait, if you haven't done it yet, I used that standard deviation as the z-score, but that's not the z-score.
Oh.
That's what it is.
Hmm.
I'll help you guys make sure you get it right. Hello.
No, Holly, that's where the power button is.
She's mad she can't see herself. She's like, hey. Let's see. So the z-score of that. The square root of 81. I don't know if that's right either. When I did it that way, I got negative 23.
Yeah.
Probability that means. Oh, you already turned yours in too, Andrea. Too late.
Yeah.
I think we've gotten 100% on all the other ones, so it's not a big deal, but I just don't know why it isn't working. I guess maybe instead of that standard distribution, like you would still use that first standard deviation instead of the one that we figured out.
Like, yeah, maybe.
0.7. Because that would be negative 2.57, and that's just a better number.
Yeah.
In which case, probability that it would be less than 3.3. But then that would only be like 0.5%, and that doesn't seem right either.
Yeah.
I guess you could try that one if you want, but. Oh, well, I guess that makes sense because 81, that's a large number, and 3.5 was the actual mean. So you could try it. It would be 0.005. And then greater than would be 9.995. You should try that and tell me if it's right. Oh, no. That's really not a fun book, I promise. Did you try it that way, Brandon?
Yeah, I haven't even I pulled it off.
Okay.
I have left the page. Let's see. They won't let me get back in it, but it's all right.
Okay. All right. Well, I guess I'll go ahead and stop the broadcast.